Good evening, everyone. Mechanics of Materials, Chapter 1, Stress. Let's solve an interesting example in a two brake systems for a bicycle. One is V brake and the other one is cantilever brake system. So a bicycle rider wants to compute the effectiveness of cantilever hand brake versus the V brake. So let's calculate the braking force RB, which applies here in both systems, and also the average compression normal stress, the average sigma on both pads and the cable itself. The area of both of them are provided, and let's consider the tensile force like 45 pounds applied on both brake systems. So first of all, let's have the dimension. So these points, if we call them point A's, are pivot points which are arced to the frame, so they are not moving. So the only moving part is when you pull up point D, like by applying a tensile force, you're just pushing the cables upward and make the brakes close the gap, and based off Newton's law, it just the same amount of force in the other direction applies to the pad itself. So this force applied to the tire and stop it from moving, and then the same force applied to the pads on the other direction. So if you look at the connection at D, we do have a tensile force pull upward of tension force like 45 pounds, and this angle is provided to be 45 degrees. And then we do have like two, we can consider both of them like TDC because they are identical due to symmetry of structure. We do know these two forces are identical to each other, and they are angled by 45 degrees from the horizon. So two of them, summation of forces in y goes 0, it just says 2 DC sine of 45 should be equal to the total amount of tensile force, upward force, which is 45. So one of them is equal to half of this force. And then if we just look at the configuration, the best point to calculate reaction at B, the best part to calculate RB force is pivotal point of A, because in that case we are removing these two forces, and then by applying this one we can easily have and cut the frame like halfway through, and we can easily calculate it like the translation or component of TDC and RB. So it just says a negative RB due to our arbitrary direction plus a y component of sine of TDC, y component times the distance, which is 1 inches. If you can easily see, this distance here is 1, so this is also 1 inches. And the other component, which is cosine of theta, this one has a distance of 4 inches. The total is 4 inches minus 1, which is 3 inches. So it just gives us, and we already know from last part, this is to half of the total amount of force, which is make it 22.5 pounds. And if you do so, it just says RB or reaction at brake is equal to 4 times 22.5, and 4 times 22.5 is 2 times 45, and it's just 90 pounds for cantilever brake system. And if we want to do the same calculation, but this time for a V-brake system, by looking the geometry of the force, as soon as you apply this tensile force of as soon as you apply this tensile force over here, it just pull the system upward. And as soon as you have that one, it just like applied as a tensile force. This part is not moving, so if you pull this part, it just pulls this part, make the gap closer and closer. And then again, by applying because this is a pivotal point, this is fixed to the frame, and then by applying a summation of moment about A, you have the distances. So again, negative RB times 1, reaction of brake in a negative direction of R moment, plus a tensile force which is 45 times 4.25 inches, and it makes it like RB is equal to 191.25 pounds for V brake system. And if we move back to cantilever system for calculation of a normal stresses in both the pad system, this is the pad, and also the cable. If we have both of those area, we already know what is the reaction. This is RB, and we do know that's 90 pounds for cantilever brake, and normal stress in pad is just reaction divided by the area of the pad. So 19 times the area of the pad, it just gives us 144 psi for a stress in a pad, and a summation, a force in the stress in the cable. So this part, it just gives us a pad cable. Tensile force, which is here, the same force apply here over this time the area of cable, which is this number 45 over 0.00167. It just give us something like almost 27,000 pound square inches for the cantilever system. And this is the cantilever system for both cable and pad. And if you want to do the same mass for a V-brake system like what we do have here, V-brake system, sigma of cable remains the same because tension remains the same, area of cable remains the same, and it's like almost 27,000 pound square inches. And if you do the mass for normal stress in pad, it just replace the brake system in V brake system, 191.25 pounds, and it just gives you definitely higher a normal stress in this kind of brake. So if you want to have a review of the two systems of brakes, if you have the V brake versus the cantilever brake for a bicycle, so sigma for pad in the cantilever one is 144 psi, and sigma for pad in the V brake is like a 306 psi. And if you want to consider the force of the brake, is definitely 90 pounds, and it's much higher in a V brake system. So depends on choosing the force or priority or the stress priority. It depends on choosing which system. Thank you. I'll see you in next videos.